So, hello, good morning, everyone.
Morning, Miss.
Okay, how are you today?
I'm good,
Okay,
Miss.
I hope you are all good. Okay, so today we will discuss about mathematical logic. So, I hope you are ready for this class. Okay, the first, what is
Yeah.
mathematical logic? Mathematical logic is the branch of mathematics that studies formal system of reasoning and the structure of valid arguments. It begins with the basic of propositional logic, where statements are combined using logical operator like and, or, and not to form compound statement and evaluate their truth. Okay, do you understand?
Yes, Miss. Understand.
Okay, next. So we also have a propositional logic. Propositional logic is a branch of mathematics that studies the logical relationship between proposition taken as a whole and connected via logical connectives. It focuses on how these propositions relate to each other through logical cognitive, such as and, or, not, if, then, etc. For example, we have the statement the sun rays is in the east and sets in the west. We know that this statement is true, so the truth value for the statement is true. 1 plus 1 equals 2, so this is true. And B is a vowel, we know this is false, so the truth value for the statement is false. Okay, do you understand?
Ini,
Okay.
understand, Miss?
Okay. Okay. We also have a non-proposition. Some sentences are not propositions because they don't have a definite truth value or may vary depending on context. For example, what time is it? This is question. Go out and play. This is a comment. And x plus 1 is equal to 2. This is open sentence. Okay. Next. Okay. Nah, so we also have logical cognitive symbol. So you can see the symbol of and is this, and this is or, this is implies, this is if and only if, this is not. So okay, the first topic in mathematical logic is negotiation. So, what is negotiation? If P is a proposition and then the negotiation of P is denoted by this, okay, which one translated to simple English means it is not the case that P or simply not P, okay? The truth value of not P is the opposite of the truth value of P. The truth table of not P is this. When P is true, so not P is false. When P is false, so not P is true. For example, we have the statement the number 7 is prime. This is true. So not P. The negation of P is the number 7 is not prime. This is false. Okay. It is raining today. So the not P is it is not raining today. Okay. All squares are rectangle. So the negotiation for this statement, some square are not rectangles. Okay, do you understand? Okay, next yeah. Okay. The next topic is conjunction. For any two proposition P and Q, their conjunction is denoted by P and Q which mean P and Q. The conjunction P and Q is true when both P and Q are true. Otherwise of false. This is the truth table of P and Q is this. You can see in the screen. If P true, Q true, so P and Q is true. So if P false, Q false, so P and Q is false. So for example, we have for example, 2 plus 2 is equal to 4, and Q uh, 5 is less than 3. So the conjunction of P and Q is 2 plus 2 is equal to 4 and 5 is less than 3. This is false because Q is false. Okay, do you understand?
Yes, Miss. I understand.
Okay, next. Now, the next topic is disjunction. So for any two proposition P and Q, their disjunction is denoted by this, which means P or Q. Now, the disjunction P or Q is true when either P or Q is true, otherwise false. Now, the truth table of P or Q is this. When P true, Q true, so P or Q is true. When P true, Q false, so P or Q is also true. And this, for example, it is sunny, and we have the proposition Q, it is raining. So the disjunction of P and Q, or P or Q, it is sunny or it is raining. Okay, the true value for this disjunction, true, because if either or both occur, okay?
Okay, Miss.
Okay, so this example too, 5 is even, and 7 is a multiple of 2. Okay, P or Q, 5 is even or 7 is a multiple of 2. This is false because both are false. Okay, next. So we also have a implication or conditional. For any true proposition P and Q, the statement if P then Q is called an implication, and it is denoted by this. In the implication, if P then Q, P is called the hypothesis or antecedent or premise, and Q is called the conclusion or consequence. Now, the implication is false when P is true and Q is false, or otherwise it is true. Okay, so the truth table of if P then Q is this. When P is true, Q is true. So if P then Q is also true. If P true, Q true. So if P then Q is false. Okay. For example, this it rains, and a conclusion, the ground is wet. So if P then Q, if it rains, then the ground is wet. Okay, so we also have and is a multiple of 2, and the conclusion and is even. So if P then Q, if and is a multiple of 2, so then and is even. Okay, do you understand? Okay, next. Now, so the next topic is biconditional or double implication now. For any two proposition P and Q, the statement P if and only if Q is called a biconditional, and it is denoted by this. The statement if P if and only if Q is also called a B implication. Okay, P if and only if Q has the same true value as this. If P then Q, and if Q then P. Okay, the implication is true when P and Q have some true values and is false otherwise. Okay, the truth table of P if only P if and only if Q is this. If P true, Q true, so P if and only if Q is also true. So this is also. Okay, for example, okay, we have proposition P, a polygon has 3 sides, and the proposition Q it is a triangle. So be conditional of P and Q, or P if and only if Q, a polygon has 3 sides if and only if it is a triangle. Okay, so the truth value of this statement is true. So this x plus 2 is equal to 5. Okay, the proposition Q, x is equal to 3. So we have the biconditional of P and Q. Okay, x plus 2 is equal to 5 if and only if x equals 3. So the truth value is true. Okay, do you understand? Hello? Okay, you guys no respond? I will next the topic. Okay. So this we also have a key proportional equivalence. So the first we have identity. Sorry, we have identity laws. Now we have a P and true is equivalent to P and P or false is equivalent to P. Okay, next, nah, domination laws. Nah, P or P or true is equivalent to and P and false is equivalent false. Okay, so we also have idempotent laws. Okay, P or P is equivalent P and P is equivalent P. Okay, next, double negotiation law. Now, the negotiation of not P is equivalent to P. Okay, next, commutative laws. Okay, P or Q is equivalent to Q or P. And then P and Q is equivalent to Q and P. Okay, and next, we have associative laws. Now, P or Q or R is equivalent to P or Q or R. Okay? Okay, and distributive laws, okay? P or Q and R is equivalent to P or Q and P or R. Okay? So you can see, okay, we also have De Morgan's laws. Not P and Q is equivalent to not P or not Q. And not P or Q is equivalent to not P and not Q. So we also have absorption laws. P or P and Q is equivalent to P and P and P or Q is equivalent to P. Okay, the last we also have a negotiation laws. P or not P is equivalent to true and P and not P is equivalent to false. Okay, do you understand?
Yes, Miss.
Okay, next. Okay, so I also have a solve problem example for you. Okay, the first one. Now show that P and P or Q is equivalent to V is equivalent to P. Okay, the solution of these problems. Now P and P or Q is equivalent to P and P or P and Q. This is from a distributive law. Okay, so this equivalent to P or P and Q. This is from idempotent law. So we get this is equivalent to P. This is from absorption law. Okay. Next, we also have a proof that uh, P if P then Q and if P then R is equivalent to if P then Q and R. Okay, we get the solution. Okay, if P then Q and if P then R uh, is equivalent to not P or Q and not P or R. This is from a definition of implication. So we also get this is equivalent to not P or Q and R. This is from distributive law. So in the end, we get this is equivalent to if P then Q and R. This is from definition of implication. Okay. As long we discussed today, do you understand?
Yes, Miss.
Okay. Nah, so I also have practice problems for you, so I hope you can try to solve these problems in your home as a homework. So, anyone to question?
For now, I think no, Miss.
Okay, thank you, Dinda, for the response. So that's all of our class today. So thank you for your attention. So see you for next class. Okay, bye bye.
Okay, Miss. Thank you. Bye-bye.
Okay.